Okay, guys,
Wait.
I'm going to give you a little more tutorial on solving by elimination. Hopefully the first assignment went well, but I want to show you a couple more complex problems. The first one actually isn't more complex. It's one of the problems you looked at, or similar to one of the problems you looked at, but I just want to talk about the process of elimination a little bit. When you're solving by elimination, the first thing you should always ask yourself is, what am I going to eliminate? And in this case, what you're going to eliminate depends on your preference. For me, what I look at are two things. First, I look at the signs. In this case, let's change the color here. Oh, never mind. In this case, I'm going to look at the plus and minus. The plus and minus is always a nice thing for me because I like my signs to be opposite. So if I have a y value in this case where one is positive and one is negative, that's a good sign that these are going to be easy things to eliminate. The other thing I always look for is, can I multiply one equation by a number to make it the same as the other? And in this case, because the bottom y value is just y by itself, it's going to be really easy to just multiply it by 3 and have it be the same as the coefficient of the top. Right? So the fact that there's a positive 3 on the top and there's a minus 1 on the bottom means it's going to be really easy to eliminate. And so I know all I need to do to solve this problem is multiply the bottom equation by 3. If I do that, the top equation I'm going to leave just how it is. So 2x plus 3y equals 3. But the bottom equation, I multiply everything by 3, and now I'm going to get 9x minus 3y equals 30. Now because I have a positive 3y and a negative 3y, all I need to do is add these together, and these are going to cancel. So those cancel each other out. Plus 3 minus 3 goes to 0. Add 2x and 9x, you get 11x. Add 3 and 30, and you get 33. And now it's just a very simple little linear equation to solve. Divide by 11, and we get our first answer, which is x is 3. All right? Now, to get the y value, I'm going to take this x value, and I'm going to plug it into one of the equations. For me, I'm going to use the top equation just because the numbers are a little smaller. So I'm going to say 2, and instead of putting in x, I'm going to put in 3. So 2 times 3 plus 3y equals 3, which means 6 plus 3y equals 3. If I subtract 6 from both sides, I'm going to get 3y equals negative 3, and divide by 3, and I get my answer that y is negative 1. So then here's my solution. And remember, I can write it two ways. I can either write it as x equals 3, y equals negative 1. There's one way I can write it, or I could write it as 3 comma negative 1, an ordered pair, where x is 3 and y is negative 1. Okay? And there's my solution. But now we're going to look at one that's a little bit more tricky. All right? Now here's another one. First thing we do is we say, well, what am I going to eliminate, x or y? Now again, that clue is here. I've got one positive and one negative. I always like to see that. So maybe I'm leaning a little bit towards the y, but now the next question, and this is the big one, is I say, can I multiply one of these equations by some number so that the y's are the same on the top and bottom? And the answer in this case is no. If I multiply the 3 by something, it's never going to equal 5, nothing nice. And the same if I look at the x's. If I multiply 2x by something, I'll never get it to be 3. So what I have to do in this case is I actually have to multiply both equations by something. All right? Now what we're always looking for when we have to do this is we're looking for the least common multiple or some common multiple that we can multiply by. In this case, I'm going to take those y's, and I'm going to think about the coefficients. I'm going to think about the 3 and the 5. I'm going to think about what is the least common multiple of 3 and 5. And the answer, the least common multiple is 15. So now I just need to think about, well, what do I need to do to get 15 for both parts? For the top part, 15 is just 3 times 5, so I need to multiply it by 5. The bottom, 15 is just 5 times 3, so I'm going to multiply that all by 3. What happens now, when I multiply this out, Because remember, you can't just multiply one part. You have to multiply the whole equation. the top, multiply it all by 5, and I get 10x minus 15y equals negative 65. On the bottom, 9x plus 15y equals 27. And look at that. I've got now two equations where I can easily eliminate, again, in this case, the y's. Because they're opposites, I'm going to add them. The y's go away, and I'm left with 19x equals negative 38. Okay? Divide both sides by 19, and I'm going to get my answer here that x is negative 2. All right? Again, I'm going to take this answer, and I'm going to plug the x value in for x in one of the other two equations. So you can choose. I'm again going to take the top one. So I'm going to say 2 times. And now, in this case, x is negative 2. So 2 times negative 2 minus 3y equals negative 13. This means minus 4 minus 3y is negative 13, which means minus 3y is minus 9. If I divide by 3 on both of these, then I'm going to get my answer, y equals negative 3. Ah, sorry, I made a mistake here. A negative divided by a negative is a positive, so y is equal to positive 3. So be careful about that. Obviously, I just made that mistake for your own educational benefits. All right? So here's the solution for this problem then. X equals negative 2, or y equals positive 3. Again, if you want to, you can write it as negative 2 comma 3. All right? So here's a problem where we couldn't just multiply one equation. Instead, we had to multiply both. All right? But we use that plus or minus sign as a little bit of an indicator of what we were going to focus on. The last problem, you'll notice, if I look at the signs, they're actually all the same. All 4 signs are positive, so that's not actually going to be an indicator for me. So instead, all I'm going to look at are the coefficients. So I'm going to think about these two coefficients, and I'm going to think about these two coefficients. And I need to decide which one is easier for me to multiply the top and bottom to get that least common multiple. All right? Now for me in this case, I like the blue ones because the least common multiple is actually going to be a little bit smaller, because even though 6 times 4 is 24, 6 and 4 are both factors of a smaller number, which is 12. So that's actually going to be my least common multiple. So for this problem, I'm going to think about turning the x values into 12. Right? So let's start doing this. So the top, to turn this into 12, I'm going to multiply by 2. 6 times 2 is 12. The bottom, I want to multiply this by 3 because 3 times 4 is 12. But remember that I want the signs to be opposite. So I'm actually going to multiply this by a negative 3 so that I have a positive 12 on top and a negative 12 on bottom. And then I'm going to multiply these across. So 12x plus 10y equals 20 is my new top equation. My bottom equation, because I'm multiplying everything by negative 3, gives me negative 12x minus 21y equals positive 24. Okay? Now again, we have something we really like here, and that is we have these two values that are the same value but opposite signs. So I can add these together, and they're going to eliminate. And what I have left then is negative 11y equals positive 44. Divide by negative 11, and we get an answer of y equals negative 4. Okay? Now again, we're going to take this y value and we're going to plug it into one of the two equations. In this case, you can choose. I'm going to actually take the second equation this time, and I'm going to plug this in. So now I'm going to write this as 4x plus 7 times, and I'm going to take that negative 4 and plug that in for y equals negative 8. This This means then 4x minus 28 equals negative 8. If I add 28 to both sides, I'm going to get that 4x equals 20, which means x is 5. So there's my final solution. So either x equals 5, y equals negative 4, or we can write it as that ordered pair 5, comma, negative 4. All right, so there you go. There's a little more help for you to look at for tonight. So download the problems. There's actually a set that are all due on Thursday or Friday, depending on when your class is. Good luck, and email me or Mr. Crosby if you have questions. All right.